Assalamu alaikum wa rahmatullahi wa barakatuh. Definite integrals, properties and interpretation. Objectives: define and apply the properties of definite integrals. Interpret the definite integrals graphically. Areas: functions and absolute values. Example 1. In the adjacent figure, C is the representative curve of a function f that is defined on R, and D is a line with equation y equal x. Remove the absolute value sign from E equal absolute f of x minus x. Solution: on interval minus infinity 0, E equal minus f of x plus x since C is below to D. Here, minus infinity 0, C is below to D, then f of x minus x is negative. Then when we remove the absolute value, we get minus f of x plus x. We multiply this value by minus. On interval 0 plus infinity, E equal f of x minus x since C is above D. On 0 plus infinity, C is above D, then f of x is greater than x, then absolute value of f of x minus x still the same since it is positive. At x equals 0, E equal to 0. Application 1. In the adjacent figure, C is the representative curve of a function f that is defined on R and x prime x of equation y equals 0. Remove the absolute value sign from E equal absolute f of x minus 0, which is equal to absolute f of x. Solution: on interval minus infinity 0, E equal f of x since C is above x prime x. Then it's positive. On 0 plus infinity, E equal f of x since C is above x prime x. At x equals 0, E equal to 0. Definition of definite integrals. Definition: let small f be a continuous function and capital F be a differentiable function on an interval I. Let a and b two real numbers such that the interval ab include in I. If capital F of x equal integral f of x dx, then integral ab f of x dx equal capital F of b minus capital F of a. Example: calculate integral minus 1 to 2x plus 1 dx. Now we want to find the integral of 2x plus 1 dx, which is equal x2 plus x plus c equal capital F of x. Then the definite integral minus 1 2 into 2x plus 1 dx is equal f of 2 minus f of minus 1, which is equal to 2. First step, we evaluate 2 here. Second step, we evaluate minus 1 here. We get 2 squared plus 2 plus c minus 1 squared plus minus 1 plus c equal to 6. Now, we want to learn how to use calculator to calculate definite integral. Now we push this button, parentheses, 2 alpha x plus 1, close the parentheses, from minus 1 to 2 equal to 6. The calculator is used when we want to check the result or if the question is calculate a definite integral, we can use directly the calculator. Application 2. Calculate integral 30 2e minus x minus 1 dx. Pause the video, then solve. Solution. Now we want to check our result using calculator. We push this button, parentheses, 2 shift e minus alpha parentheses x minus 1. We close the parentheses from 3 to 0, which is equal to 1.0995, which is equal to 1.0996. Properties of definite integrals. Definition: let small f be a continuous function and capital F be a differentiable function on an interval I, such that a, b, and c belong to I. Integral a of x dx equal to 0. Integral ab of x dx equal minus integral ba of x dx. Integral ab of x dx equal integral ac of x dx plus integral cb of x dx. Example, given I equal integral 1 2 of x dx plus 2 3 of x dx plus 3 4 of x dx, write I using an integral sign only. I equal integral 1 2 of x dx plus 2 3 of x dx plus 3 4 of x dx, which is equal to 1 4 of x dx. Here 2 2 3 3 are removed, we get integral 1 4 of x dx. Application 3. Given integral 1 2 of x dx equal 5 and integral 1 7 of x dx equal 8, find integral 2 7 of x dx. Pause the video, then solve. Solution: integral 2 7 of x dx equal integral 2 1 of x dx plus 1 7 of x dx, which is equal to minus 1 2 of x dx plus integral 1 7 of x dx equal minus 5 plus 8 equal to 3. Geometric interpretation of definite integrals. Let small f and small g be two functions defined on an interval I such that the interval AB belong to I. Let C and G be the representative curves of f and g respectively. We show the figure. This is the curve C and this is the curve G. The area of the domain limited by C and G and the two lines x equal a and x equal b equal integral ab absolute value f of x minus g of x dx. Let f be a function defined on an interval I such that interval ab include in I. Let c be the representative curve of f. This is the graph c and x-axis and the two line x equal a, x equal b. The area of the domain limited by c, the abscissa axis, and the two line x equal a and x equal b is integral ab absolute value of x dx. Example 4. Let f be the function defined as f of x equal x plus e minus x minus 2. Let C be the representative curve of f in an orthonormal system. Calculate the area of the domain limited by C, the abscissa axis, and the two line x equal minus 1 and x equal 1. This is the area colored in blue. This is the curve C, the abscissa axis, the first line x equal minus 1, the second line x equal 1. The area equal a equal integral minus 1 1 absolute value f of x minus 0, the equation of x-axis, equal integral minus 1 1 absolute value x plus e minus x minus 2 dx. Since c is below to x-axis, then the value within absolute value is negative. C below x-axis, then f is negative. Then we multiply the value within absolute value by minus. We get integral minus 1 1 minus x minus e minus x plus 2 dx. Now we want to solve integral minus x minus e minus x plus 2 dx. The integral of minus x is minus x squared over 2. The integral of minus e minus x is minus e minus x over minus 1 plus 2x plus constant, which is equal minus x2 over 2 plus e minus x plus 2x plus c. Then a equal integral minus 1 1 minus x minus e minus x plus 2 dx equal to the antiderivative between minus 1 and 1. First, we evaluate this function by 1 minus, second we evaluate this function by minus 1. We get a result 4 plus 2e minus 1 minus e, which is equal to 1.65 units squared. Now, if 1 unit equal to 2 centimeter, then the area in centimeter is equal 1.65 times 2 centimeter square. 2 is power 2. we get 1.65 times 4 to square equals 6.6 centimeter square. In this way, you change the area from unit square to centimeter square. Application 4. Let f and g be two functions defined respectively as f of x equal x plus ln x and gx equal 1 plus ln x over x. Let c and g be the representative curve of f and g in an orthonormal system as shown. This is the curve of G, and this is the curve of C, and this is the line of equation x equal E. First, verify that A11 is a point on C and on G. Pause the video, then solve. Solution: f of 1 equal 1 plus ln 1 equal 1. Since ln 1 equal to 0, then A belongs to C. Same, g of 1 equal 1 plus ln 1 over 1 equal 1. Since ln 1 equal to 0, then A belongs to G. 2. Verify that x ln x minus x plus c is an antiderivative of ln x, where c is a constant. Pause the video, then solve. Solution: we derive the function x ln x minus x plus constant. We get ln x, then x ln x minus x plus c is an antiderivative of ln x. 3. Calculate the area of the domain bounded by C and G and the two lines x equal 1 and x equal E. Pause the video, then solve. Solution: 3. A equal integral 1e absolute value of f of x minus g of x dx. Since c is above g, then the value within absolute is positive. Then we remove the absolute without change. Then we have integral 1e x plus ln x minus 1 plus ln x over x dx. We know that integral ln x dx equal x ln x minus x plus constant. Integral 1 plus ln x over x dx is equal, let u equal 1 plus ln x, du equal 1 over x dx. Then we change the variable, we get u du, which is equal u square over 2 plus k equal 1 plus ln x square over 2 plus k. Then integral x plus ln x minus 1 plus ln x over 2 dx is equal to x2 over 2 plus x ln x minus 1 plus ln x square over 2 plus L. A equal integral 1e x plus ln x minus 1 plus ln x over x dx, which is equal to the primitive found in this part between 1 and e, which is equal, first we replace x by e minus we replace x by 1, we get a result equal e square over 2 minus 1, approximately 2.69 units square. Application 5. Let f and g be two functions defined respectively as f of x equal x plus ln x and g of x equal 1 plus ln x over x. Let c and g be the representative curve of f and g in an orthonormal system. Calculate the area of the domain bounded by c, g, and the two lines x equals 0.5 and x equal e in centimeters square, knowing that 1 unit equal to centimeters. The two curves shown in this graph. Pause the video, then solve. Solution: A equal integral 0.5e absolute value f of x minus g of x dx equal 0.5e absolute x plus ln x minus 1 plus ln x over x dx. First, we have here between 0.5 and 1, we have c below g. Then, when we remove the absolute value, we want to multiply by minus. Between 1 and e, c is above g. Then, we remove the absolute without any change. We complete. We get 13.68 centimeters square. Assignment: Worksheet 24A, Worksheet 24B, Worksheet 24C, Worksheet 24D, Summary.